Right, so I think we should be live again. No idea if we are really live. I'm gonna see in a second on YouTube if everything works. However, it should work. I use the same settings, so I hope I'm fine, but Windows, you never know. So, welcome back to the stream, to my game engine development stream, and yeah, that's the topic of this video today. This video stream, yeah, however. This is of course again totally unstaged. Let me quickly see if everything goes on live. Yeah, there it is on YouTube. Let's do my whole setup that I do. My chat in the different window. Put the chat here. Let's see how we are going. I think the music might be a bit too loud. I don't know if epidemic sound is really. Just gonna bump it a bit down because it was a bit loud for me. I'm gonna see and roll the stream for a few seconds, and then as always I'm gonna check if everything works. So I'm gonna do a quick test and pause my music again to see if everything works. This really, just gonna bump it a bit down because it was a bit loud for me. That looks good. That looks good, that looks good. So we should be on track now. So here we are. Welcome to the stream, welcome to Game Engine Development. Today the stream is a bit earlier than expected. This is because I do have another appointment later on this day, and that's why I just started it a bit earlier than I intentionally planned that, but I hope that's not an issue. Let's get my backlight a bit up. Let's see, can actually... I'm gonna try something new today to boost up my face with the video. There was a color change here on this app. Oh, this does only work in full screen. That's not nice. I have no idea if this is gonna work. We might do this. I might do this on the different monitor and just monitor the stream there. So my idea is to use my monitor as a light that is illuminating me, because just having a white screen on there until I might have a proper setup. I need to take a look at this. Maybe I can buy a light tomorrow or next week so that I have a proper streaming light and not everything that I have now. However, this is now at least I think a bit better. If I look at this side with my head, then it might be good, but I can't see it because if I look on my monitor I can't see my stream preview. But I think it's good. Alright, so welcome back to Game Engine Development. I have done a few things since last stream. Actually, I've changed my mind. I'm gonna do a bit of hardware abstraction layer, especially when it comes to the window, because I think that it can break too much things. However, I'm gonna not implement hardware abstraction on the stream here. We already talked about the window in quite some extent and doing some hardware abstraction between there. Or it's actually not more even hardware abstraction, it's more like operating system abstraction, because like all hardware is nearly the same. It's like all major AMD CPUs or Intel CPU x64 and either NVIDIA or AMD GPU. I mean, it doesn't matter if it's PlayStation, Xbox, Windows computer, so desktop computers. The only main difference is the operating system, right? So it's more like an operating system abstraction layer, but you kind of like call it hardware abstraction layer. But yeah, a few things have changed concerning the project layout. Basically, I have moved the window project into a different module. I might open this up very quickly with Visual Studio Code so that you can see it as well. Let me zoom in here. So basically what I've changed is that now basically previously the Windows code was inside Engine, now it's all inside of inside HAL for hardware abstraction layer, and we have several folders in here. We have contract, which is basically defining all the contracts that a layer or abstraction layer implementation needs to implement. In this case it's a contract for windowing, which has an interface for the window factory. This is already implemented, and an interface for window itself, which is not implemented yet. And basically this is going to give us a platform independent description on how Windows or windowing should work. And I rather tend to describe it as windowing instead Windows, because Windows is like easy to mistake with the operating system. Alright, so what we then have down here is the implementation folder. In this case, we have an implementation for Windows, and basically this is giving us everything that we need that we need on Windows, basically. So, for example, DXGI, which is always required, is inside of Windows. I don't know if I think Vulkan does not like use a DXGI swap chain, but it kind of like manages DXGI objects, because DXGI is like the infrastructure to put something on the screen, even if you are using different graphic APIs. Alright, so do we have a bit of Windows stuff in here, and basically the idea is that we're going to write some common stuff in the contracts ones, and in the implementation we're going to write our actual code for Windows. It doesn't really like a big deal to deal with that. I'm going to also have a mapping project in the future which maps these automatically, but that's all something that I'm going to do off stream, because it's so what we have here now as well is we have something in the Windows folder, the DXGI, what we have done last stream, which didn't work, and I changed a few things in here. What we basically have done was that code, and what we basically have done is we tried to get the debugging interface, and it failed. This failed because the debugging interface needs to be loaded from the DLL. It's like needs to be dynamically loaded, and the DLL is not automatically loaded. So basically what was missing is load library XW call to load the library from system32. So basically load the DXGI debug library to then get the function from the debug library using the debug DLL handle. But basically putting these two functions together, so get proc address and load library XW for the DXGI debug DLL, was basically possible to basically do a thing. I might need to update a quick thing here. Can I disable that? Yeah, I can. Good. I just needed to change a setting on the stream, but we're gonna get to that later on. There we go. So, alright, so this is basically the idea here. If you're doing these two functions together, everything works. You're getting the DLL dynamically, and you're getting the function dynamically. And basically, if you're doing it like that, everything works, and it gets together, and you have your debugging interface you can use for debugging. After that, I just called the create DXGI factory function. I think we already did that on stream, and it worked. So if I would try to debug this now, I have no idea where I put the demo code for that, the way that we can check it, but I'm gonna find it. No, I didn't want it to close DXGI. Let me open up my example, my app.cpp, and there we have it. Here's the call to init, and let's do 2 breakpoints here and see what we get. So let's start this and see what we are dealing with. Alright, so now we are here at the call to init. I do have a bit of disassembly as well, but we don't really care. So if I continue with that, you can see that we have called the initialize function. Now I can take a look at this by going to my watch and doing the S instance. And if I would take a look at this now, I think I have the zoom screen, but I think the zoom screen is it working? No, not really for the purpose that we are doing. So let's maybe, I mean, the most common thing that we're gonna do is debugging, so the zoom screen is probably fine to always peek at my debugger. Yeah. Alright, so basically what you can see here down the debugger is that the status is ready, that the factory is a proper DLL, that the debug DLL is a proper handle, and the DXGI debug com pointer itself is also valid. So it has all the function pointers that it needs, basically. And that's everything that we need to get the debugging interface. Now we can kind of like start working with that, and that's the first thing that I want to do. The first thing that I want to do is I want to write my cleanup, or not my cleanup, but my debugging checks that I'm gonna do. So what we're basically gonna do is we're gonna have a function here that basically shows us that invokes the debugging routines. So we're gonna have a void Report live devices. Device objects. No, report live device objects. RLDO. Is it const? Probably it's const. Non-exempt. I know. We're gonna have the function here. This function only gonna do is only doing something on debug. So if PDK, how did I call this? PDK, no, ProEdgeGFX debug. Okay. And only if we are on debug are we gonna have an implementation in this function here. If we are on release, it's gonna do nothing. Alright, so what can we do? DXGI debug has a few functions. It has, come on, give me hints. What? Alright, because it's not const. Okay. We might need to implement a const of that as well in the comp pointer, but yeah, we're just gonna get rid of the const here. I mean, it's in this case it's not a big deal. However, we might implement this later on in the future to be 100% const correct. Come on, give me hints. Come on. IntelliSense. Alright, so my IntelliSense is not working. That's amazing. Why does it not know the debugging interface? I mean, I can see what it's doing here in the header, but I would love to also get what I need. So we don't really care about these two. However, we care about the other one. I think it's not visible there, though. Yeah, that's the function we are looking for. Report live objects. Let's go to the implementation here. Do you know now what I'm doing? Interesting. What is wrong with you? Can I do the factory? Or do I have a general error in my code? Okay, it seems like I have a general error in my code. What did I mess with my comp pointer too much? What did I destroy in my comp pointer? The pointer operator. CT pointer operator pointer. Returns a pointer which is a CT pointer, and CT is in our case remove pointer T from T. So this might be an issue because this isn't a pointer. Can it be? If I would like say CT like that. Do we need to do it like that? Doesn't that work? It would be bad if it doesn't work. Yeah, okay, so we need to do it like that. Okay. This is something that I might as well want to change on my GitHub page. Let's get another tab here. Open and see what we can do. So edit. So this is CT and we remove that. So you should never try to be too smart, right? Okay. Now we can use the function. Okay, so we need an app ID. Now I need the documentation for that function. Haven't used it in a while. Use one of the debug IDs, alright. So we can have basically select what we want to get for debugging messages, or what we want to check. DirectX and DXGI objects, just DXGI debug app, debug D3, D12, or just all, and I want to get all. And as far as I know, these GUI IDs are hidden in a quite strange place. But we're gonna get to this in the future. If it fails compiling. Now the next thing that we need is flags. We can basically tell it what we want to do. So what we basically want to do is we want to ignore internal objects. We don't care about internal stuff. We just care about stuff from us. And we want to have a detail. So XGI are these two things basically. I'm gonna read them out now. So that one. Or that one. And I think there was some issue that they were not defined, right? No. Because they are ints and there was that issue. So basically what you need to do is you need to cast them to a flags. Basically you need to do this like that. You know, and I think you can combine them, right? And no, I think they are combined. They were possible to combine. So we're gonna report the live device objects. This is returning an H result, and if this. Okay, now I think I had the check function in itself. Check HR and throw. We had the expression and the description. Expression. Description. Description is... Always tend to do it like that. I like to copy them and then basically say what I have done. And I like to always hide them because you always know what's going on there if you take a look at the source code. But to just get us some hint for an error message, a potential error message. Now let's see if it fails. Probably it fails. It doesn't fail. That's nice. Something that is not always expected. Right now I want to call this function actually automatically. Do I want to call this? I might call this automatically in shutdown, right? And then on the destructor. One thing that we want to do here, of course, as well is we want to check if status is equal to ready. Only if we are ready, we can report live device objects. And then we just want to make sure that we call this before shutdown. So if we start this, we should already get something when we close everything up. Or we might get nothing because we don't have the XJ objects. I don't think it's telling us something if we don't have anything. Yeah. It's not telling us something if we don't have something. It would output them basically here to that console down here. Alright. Now let's try to fake it and make it able to throw an error. But before I can do this, we need access to the factory. How are we gonna do this? We need to basically return a... Do we copy that whole pointer or do we return a non-reference count one and hope that the user... No, I think we were gonna do the save. So we want to return the factory itself. So we want to have an inline get factory. No, const is not allowed because then I have a const comp pointer, which is not something that is valid, and basically I am returning the DXGI factory here. And now what I can do, I could try to leak that factory pointer. That needs some workarounds to leak that pointer, but we can do it. So how would we be able to leaking this? IDXGI factory 7 ft is equals to Instance, get factory, get without ref. Well, actually, I do want to get ref, alright? What is wrong? Because get ref is gonna reference that, add a reference there, but returns the raw pointer. And this is then an issue. Because we now have an add ref, but we never call release ref because it's a raw pointer. Okay, we need the full namespace, of course. This is now basically leaking a factory pointer, and this should be catched, hopefully, by the debugging interface. Do we get an error message here? I didn't get one, that's bad. But I'm not sure if the factory is actually supporting that. Also it might be that the factory is not even able to be detecting things on the factory itself. However, that is kind of odd. But maybe it is not, because the factory is, I think, a singleton. So I think it doesn't matter how many times you call the get DXJI factory, so it's a singleton, so it doesn't really care about add ref and release ref. We need to basically tell the factory to do something to leak it. So when we're doing something like, we can still keep this, let's say auto factory equals to get factory. Now we have a factory, that's a com pointer, and I can say something like enum adapters 1 maybe, which gives me an adapter here. It's an IDXGI adapter pointer, so if I would do this like IDXGI adapter 1 pointer, just some simple bad code like that. And this should now give us a reference count object that we are now leaking because it's not wrapped in our com pointer. So if I would have started like that, we should have a leaked adapter, which hopefully is detected by DXGI. Or is it not really? It's interesting. I'm not calling that report live device objects. Interesting. No, I didn't want it to step over. I actually would have stepped into, but pressed the wrong button. Let's see. Yeah, would be F11. So I get the instance. And I call shutdown on the instance. Ah, right, I call shutdown and not a destructor. Okay. So it is in the wrong place. I do not only wish to call it there, I'd like to call it on every shutdown. Like there. And this should fix it. Because we're not automatically cleaning this up. And this should now give us an error message, hopefully. Doesn't give us one. Is DXGI just reporting to an info queue? Might be. But it should give us that. We can try it out again. I could also try to create a DirectX 12 device. This would also throw us down. With the pointer. We should have another call at some point. We don't have a call? What? I need to press F11 in here. Did we not call report live device objects? I'm kind of missing a call there. We're calling like the operator. Then we're like, this is DXGI debug all. Alright, this is that one, that JGE, because this is a com object. This works a bit different. No, it does not work different. This is basically because it is a function pointer. Right. It's not a... Or is it? What are we doing here? What? Okay, like this is the exception thing. CCX or exception. This is the call function that I was looking for. I'm an idiot. Alright, can I put that down in here? Maybe. I don't think so. However, this should have called the function here. Mod debug. Here, there we go. So it might be, but I think there was a thing that like the DSGI objects those are not really properly reference count. Let me do one quick thing to at least get a third of my chat. No, that was the wrong window. Damn it. Right, like that. What exactly? How you wanna start with what? To the chat. Let's quickly check if we can leak or check DirectX 12 objects if we leak. Of course, it's not included. Do I not load Windows currently? D3D12 create. Ah, no, it was like that, right? Null pointer D3D12 feature level 12. D3D12 device. ID 3D12 device. Default, just like that. This is gonna go. That code. I just try to leak objects currently. What? Oh, yeah. Right. IID, PPV, args. IID, PPV, args, like that. Do we... I think I removed DirectX 12, but no, it's still in there. Let's see if we can check that leak DirectX 12 object. Alright, so this does not seem to work as expected. But it might be just reporting to a message queue, like the XGI is a bit bitchy. Especially if you're using like its own debugging layers. Or does it not able to use both of them? But should be. Let's see in the documentation what this is doing. So this is an example, I think. Oh, come on, I don't want to go through like the whole Microsoft example. To find like an report, so maybe we find something quick. Where could it be? Context. Of course not. And then it might be in the framework or in the log. Alright. Ah. It's an ISDXGI debug 1. So we might just check the summary. If that works. No, I want to close. Or do I miss something? I might need to take a look at some more code of mine. So, as well as the adapter, also the DirectX stuff is all loaded. Or do we need to enable the debug layer so that we do... We might need to enable the debug layer at some point. Will there be something that I missed? I know that we need to do this on DirectX 12, but I don't know if we need to do it on DXGI as well. So I might need to do something like But I think, no, like DXGI debugging should be there automatically, but we might need to enable DirectX debugging first so that we can handle that. Might try that out. So D3D12 get debug interface ID PPP args to ID 3D12 debug it's just called debug, yeah, debug 1. I could wrap this in a com pointer now. Yeah, of course. IDXGI12 debug. ID 3D12 debug 1. You can say debug, enable debug layer, and then this might work. Yeah, that's now working. I can basically see how it works. So it has a device, shader cache session, root signature pipeline. Why do we have so much? Live producer add. Yeah, I called that. We might need to do this, like now let's first go back to the instance. And let's bring back the original one. Like that. Let's see. We get now. So we need the debugging layer, of course, before that. So let's close that one and close that one and see what we get. D312 warning, but I don't know if this is like the real warning. We might need to leak that. I'm gonna try this again, because this might automatically clean up after itself. And if we don't clean up after that, then it might go through DirectXGI. No? I mean, it's like reporting here, but then it reports again. As you can see, like, this is like the report coming from DXGI. So maybe zoom in. The first one is coming from DXGI, reporting DirectX 12 objects, and then after it, process is terminating using simple reporting. But it tells me to call this at runtime. Interesting. But I think we don't care about that. Really. Just gonna be fine with that for now. So just gonna assume that this works now. Alright. Now let's start implementing a bit of what do we want to implement? Do we want to implement the graphics window first? But I would love to actually do my hardware abstraction layer before that. So what I might implement now is just some GPU enumerating and general rendering layers, hardware abstraction layers. So we might have something like RI is like renderer infrastructure, and like I think Unreal Engine calls it RHI. I like to call it RI, but RI is like a bit mistaking. However, I think it's also fine. Is it fine? I have no idea. I'll just call it RI for now. Need to get the same thing in here. Now this is not called like that, it's like that. And like that. Now we have a new project. Now we should be able to run dev2, generate project, and get a new solution, a new project in our solution. Now we can go in. Let's first do another build to see that everything works. Yeah. And now let's add in some code. So what do we want to get? We want to first, no, not a filter, not a filter, not a folder, nothing in that extents. I could try to like move this down so that you can see it as well. Yeah. So how gonna call this? This is gonna be like the basic interface. Hardware interface. Hardware interface.h. That's the holy header. So namespace is pdk hal ri renderer infrastructure. So we have the class hardware interface. And the hardware interface is basically responsible for retrieving... no, it's not Java. I've written a bit of Java and I'm already making things wrong in C++. That's ridiculous. Right, so basically what idea is that the hardware interface is able to enumerate GPUs and stuff like that. So do we want to have an iterator for that? That's a big question. Do we want to have an iterator for enumerating GPUs? We might want to have one, but this requires us to write another interface. Then we need to get a reference, we cannot get an object, we need to have it templated. No, we're gonna write this plain, we don't want to have an iterator for that. Or we might have one later. Yeah, we might have one later. So, and this is of course virtual. So we're gonna have a virtual GPU info. That's the question. I would like to create an own header for that. Probably. So let's add one here. New item. Let's call this GPU info.h. And let's start by copying some stuff over there. And let's now call this struct I GPU info. Actually, it's not an I GPU info, but it is kind of like, it's more like the GPU info base. Because it's a base class that has like all the default parameters in there. And then we're gonna have a Windows thing that then basically adds Windows specific stuff. Or like DXGI stuff. So what do we want to have about the GPU? We're gonna have a name. And I think, as far as I know, this is what name do we get from that? DXGI adapter. I think it's a white string name. Which is gonna be bad, because then we need to convert this. Why are you doing that to me? Oh, I'm just gonna put a white string in here. We can always like go back. I rather have a white string and convert from other libraries that don't use white strings into white strings than like reducing maybe something that's written in Windows. So we're gonna have a name of the GPU. We already have it open. We can see what Windows gives us as well. Dedicated video memory, system, and shared. This local UID, that's something that we don't care about, but what we care about is video, shared, and system memory. How am I gonna call them? So yeah, I think just video memory, system memory, and shared memory, or shared system memory. I don't know if we really get this all out of Vulkan as well, but we're gonna put it in here anyways for now. Just to get started. Now, is there anything else that we might be interested in? We might be interested in the description 1. Is that really containing something more than that? Flags. What are these flags? Do we care about something of that? That's something we might want to care. Software, remote, and adapter. So we might have a enum class GPU type. And we're gonna have a GPU type generic. Or let's just call it hardware, software, and remote. So we can basically encode the type there as well. We have a basic description about the GPU. So this is like basically what the GPU looks like in a hardware abstracted way. Now let's include this one here. So PDK, HL contract, GPU info. Basically what I want to have is a virtual boolean get GPU, or yeah, just get GPU info. We're gonna have an index, and we're gonna have an enum class enumeration order, and the enumeration order is gonna be default or by performance. Like Windows allows you to enumerate GPUs by performance, so that you're always gonna get the most performant GPU first. And this is something that I want to have here as well. So we kind of like have this virtual function here that's basically responsible for enumerating the GPU, and later on we're gonna have a virtual function to actually create an interface for the GPU, like a DirectX 12 device, which is basically then gonna get an information on which hardware abstraction layer you wanna have. So later on we're gonna have something like GPU interface, and we have something like virtual create interface, and then you like have a GPU info or info base reference info, and you're gonna get why is it undefined? Yeah, because this is like a bit bad here. It's not really checking that. This is like an issue if you have a header only files with premake. They are not gonna be detecting the IntelliSense right at the beginning. Then you're gonna have something like parameter here, something like desired hull equals like D3, D12 or something like that, or Vulkan or something like that, to basically then retrieve an interface to the GPU. But for now we just want to get the info itself as a, of course we need to output this as well. So GPU info base reference out, and it's going to return true if it is able to do this. Now we need to implement this basically, this class. How can we implement this class? We're gonna go to our DXGI instance, because the DXGI instance will be able to enumerate them. And basically what I want to do is then include the hull. Like, this is windowy stuff, but that's okay. Actually, contract RI hardware interface, because it's basically what we are. So basically we are a RI hardware interface. And to be one of these, we must be able to implement the virtual method here, the get GPU info. And that's something that I always need to remember, to add these things here by default. And if we override, yeah, we can do this like this, I think. So this is like the interface that we implement. And basically, what I want to do now is enumerate the GPUs. However, I need to do one more thing. I want to have a struct. GPU info. This is gonna be a DXGI GPU info, or GPU info DXGI. So we have like had the base class, and now I'm basically having the DXGI thing. But what I do want to do quickly is just out of, okay, this is also, Paddles also populated these. What I would quickly want to do is I want to rename this to add an underscore in here. And then I can do this properly here. Makes a bit more sense syntactically. So this is not a public RI info base, and basically what we are doing is we are adding something to that, and we are adding a local UID. We are basically adding this local UID in here so that we are able to later on find a DirectX GPU based on that. So that's basically what I want to do here. Now inside get GPU info, we need to do a few things. So first of all, I'm gonna boolean, I'm just gonna return false. I like multiple return statements, so it's fine. First thing that I want to have is a GPU info DXGI pointer, which is my DXGI info, which is going to be equal to a dynamic cast to GPU info DXGI, which makes that no longer required. So we can do this as an auto pointer actually. And we can take that. Well, no, that's wrong. I'm an idiot. Oh, no, I'm not an idiot. I'm not an idiot. Everything is good. I can take a pointer to out. Yeah. I don't care what you're doing. I'm just gonna do my plain old... I'm just gonna do my plain old castings if you are trying to screw me up. Old casts always work. C-style casts. But why didn't you want to have dynamic casts? It's really interesting. Because I could just like dynamic cast. Like this is hierarchical. This is the super type. And this is the base type. So this is actually should work. Or do I need to cast this to an RI pointer? Why is it not working? Maybe because we don't have a virtual thing in here, so we might do a virtual destructor to force it to have a vtable. If we now force it to have a vtable, we might be able to do it. I mean, we could get away without vtables. Yeah, it's a vtable issue. Because if you don't have a virtual function in here, no vtable will be generated because it's like unnecessary. And then dynamic type checking does not work. Now I could sacrifice this, but since for performance and say, right, I do want to have a bit more performance structures. And then I need to cast my things manually. However, this is not something that's going to be called once. Or maybe a few times, like 2-3 times on the launch, when the game starts. So that really doesn't... It's not really an issue if we do it in the unperformant way. By wasting a bit of memory and a bit of CPU cycles to do runtime checks. So if the CXGI info pointer is valid, then we know everything is good, and now we just need to fill all the data out. Now, how do we want to do this? We need to enumerate the GPUs. This is going to be done with the factory. So I can basically say enum adapters. Now, enum adapters has 3 functions that we can use. Actually, we have 5. We can enumerate them by GPU preference. We can enum them by the local unique ID, by the adapter and the adapter 1. Adapter 1 is just a newer version, and by warp adapter. Warp is just software. I don't care really about software adapters. I just care about enuming them normally by GPU preference and by the local unique ID. So now this is resulting in an error because now we basically need to have 2 cases, and basically what I want to do is we want to have 2 functions for this because that really doesn't make sense. This is now also, let's also do a result here, which starts at false, and we're going to return it. I don't like that. No, we're going to do single return types. However, like I want to like basically check. How did I call it? The order? It got rid of the name? Because I probably screwed up somewhere else. Yeah. Order. So if enum order equals RI enumeration order default. If we are default, we're going to do it by default. Else, we're going to do it by the preference. And we're going to implement this in a second. Hi, hello, welcome to the stream. So what I basically want to do here now is write 2 functions for that. With the DXGI. Did I already close the header again? No, it's there on the left. So basically I want to have a few private functions that do the stuff. So I'm gonna have a boolean enum or get GPU default. This is gonna get the index. It's gonna get the actually gonna get a GPU in for the XGI reference out here, so we already know it and we don't need anything else. Then we have preference, and this is also gonna get the DXGI enum DXGI GPU preference. Yep, there we go. Preference. This is a const reference. I don't know. Probably this is like a small type, so it's like really pointless to do it as const. We have like minimum power and high performance. These are the two things that I really care about. We also have unspecified. Yeah, we could also use... Alright, so we just actually need to write one function for that. That's good. We can just pass an unspecified there. That's good. If we use unspecified, it's probably gonna enumerate them normally, right? Can we take a look at this? So I do like the factory 7, please. To just get the... Where's the enum by GPU preference? There it is. So, adapter. As the output... no, the index, the preference, and the output. Right, this is like how we want to do it. Alright. Integrated, discrete, external. External, discrete, integrated. Yeah, that's nice. Yeah, equivalent to calling enum adapters 1 if you have them unspecified. That's the thing that I was looking for. So we can basically use this function here, that's good. And we basically now just need to implement this one function, that's nice. So we're going to create the implementation here. And now we just need to basically do it like that. And I want to do this now differently. Now basically I want to switch on my enum order. And what I basically want to do is case performance. I run a return, get GPU preference, index, dereferenced DXGI info, and then I have like high performance in here. Now I also said by performance, where was it? Like I have default ones, then by performance, and I also want to buy low energy, so by efficiency. Maybe efficiency, but efficiency is also wrong because a bit fat new AMD GPU or NVIDIA GPU might be more performant, have more performance per watt than an older GPU, like because it can do more per watt, but it still like consumes more. So buy low energy is actually more correct. And basically, what we're gonna do is we're gonna do a few checks there. So we're gonna have buy performance, buy low energy. Minimum power. Then we're gonna have default, which also goes to the default case. I mean, we can like, how was that? Fall through? Like that? Yeah. So that we don't get any warnings there. DXGI, GPU, unspecified. And now this should be good. Now this should redirect us to the proper, with the proper values that we want. Now we just need to implement that one. So basically what we want to do is we're going to have a com pointer, IDXGI adapter. Which versions of adapter do we have? Like let's take the most complex one. IDXGI adapter 4. Do we have 5? No, 4. Sorry. So it's the adapter. And basically what I want to do is if succeeded, return false. What does need to succeed? So factory enum adapted by GPU preference. So the input is the index here. The preference is here. And the output is IID PPV args of adapter. And if this succeeds, I want to get the description 1. So step 1 is like get adapter. Actually, let's do this a bit different. I like to do it more like if that failed, we return false, something like that, because this looks it's a bit more streamlined from the code. Now DXGI GPU DXGI adapter description 3. There's already a description 3. What's inside 3? Flex. Compute preemption granularity. What is that? I don't know that actually. DMA. Alright, so this is basically giving us some. No, 1, 2, 3, 4. Okay. Okay. Interesting. Don't know what this means, but having more values than we need is always better than having less, right? Okay, so let's just get the 3. Description. Adapter description. Now, this is a different call. Now, here I actually want to throw if we have an error. Because if we are getting the adapter itself, this should succeed. So, adapter get description 3. Do we need to set the CB size or something like that? No. Just like that. What's going on there? Well, actually, I think I actually integrated these. Maybe we should give an error message here. Like, failed to report living device objects. Debug. Then we might do something like here. Failed to retrieve details of GPU adapter. And if we succeeded down to there, we're just gonna fill in the data. So out, now we basically want to fill these. First, the name is gonna be equal to after description. This should automatically fill this in. Now we have a type. Okay, now that's... we need to actually check for the flag. This is more hard to fill. Video memory. Dedicated video. Dedicated system memory. So now we have the shared memory that we have. And I might actually even... No, we just do it like that. Local UID is going to be equal to the adapter description, adapter local unique ID, name, memories, and I think that was everything. Just the type that is missing now, and the type is going to be dependent on what the flags were. So the flags can be remote. Oh my god, there's way more in here. Okay, this is just monitored. So remote and software, we have remote and software. So basically I want to check if adapter description and the XGI remote. How was the member called? No, because it's like wrong. Adapter description. Hello? Why is my IntelliSense bitchy? Just flags. So if that and some values, if I peek that, I can find the flag itself and copy them over. So adapter flag drive software and remote. So if that is the case, out type equals software. Let's do this properly. Out type and else this hardware. So this is basically gonna retrieve details. So this is allowed to fail, this is not allowed to fail, and then it's true. And that's exactly what we want. Okay, so... Let's see. What do we want to do next? Like, this should work now. Next thing that I might want to do is I might want to write an iterator for that. Which would kind of like go in here, but yeah, we can do this header only, that's okay. So, basically I want to have a public plus iterator. This iterator is gonna have a few things. First of all, it's gonna have a hardware interface reference source or interface. Then I'm gonna have a current index. These are like the two parameters that I need. An iterator itself is constructed by another one by a default conversion. They can be assigned by a default conversion. They can be not created like that. They at least need a hardware interface reference interface and an optional size t index that starts at 0. Is interface a keyword? No. Shouldn't be. No. What are you trying to do, Visual Assist? Interface. Like that. It looks like that. Let's just call it a... Current index. That's everything that we need. Now we need to implement a few operators if we want to have an iterator. So we're gonna have a boolean operator equal with a const iterator other. Can actually be no except here. I don't know if it's default no except. I don't think so. Basically, what we want to return is current index equals to other current index and interface equals other interface. No, like that. Then we're gonna have other increment operators. I don't always need to take a look how they are implemented because I want to have both. Like the first one is straightforward. The first one is iterator operator plus plus. This one is like the pre-increment one. This is a post-increment one, I mean. So basically what this is doing is kind of like saying current index plus plus and it's gonna return dereference this. And copies that over, right? That's straightforward. The other one, I might get this one. I think it's... Was it like that? I think yes, because it's basically doing copy of dereference this. Then it's incrementing the index and it's gonna return the copy. That's the idea, I think. Right. No, that's not the page that I was looking for. I was looking for that one. Okay, so... Alright, they can have references. We might want to implement the reference one either than the other one, because the one with the reference is... Right, you can convert the reference to something else, but I think it's better to do the reference one. But it doesn't work on that one because it's a copy, obviously. We can do it here, but not with the copy. And this one is, I think, a bit cleaner, because if it's just going to use once, it can automatically use the reference. It just needs to compare it. Now we can compare and increment. This is like the most important thing on an iterator, on a forward iterator. One more thing that we need to do is dereference and use a pointer operator. So the pointer iterator is going to be very, but it needs to be a pointer type if we have a pointer iterator. Dereferencing could be nice. Because basically it's a GPU reference. Or do we just store it internally? Then we can also use pointer operator. Yeah. We cannot use the iterator, we need to make that actually templated. Okay. Cannot do it like that. That's bad, but I'm just gonna not implement an iterator. But I already spent so much time on writing them. Alright, let's just do it. We can make them in class, it's not a problem. We can, but the only thing that we cannot do is then support automatic iterators. This is not gonna work, but okay. So let's make them template type name t. Type name equals std enable ft. Std is base of value, so the base is the hardware, the GPU base, and this is t. I don't think that we have type traits. What is wrong with you? Yeah, okay, that's the same issue then down there. Okay, that's good. So this works. And basically what I want to have is like the iterators moving, but it's like more accessing data, so we need to cache them. So what we're basically going to do here is we have a tm info. But we don't really care about the info. The info is only filled when it's requested. So private, we're gonna have a void get info. Actually, let's make this a t reference get info. It's automatically retrieving like the information for that, and the t get info needs to kind of like query the interface. So it's calling the get GPU info here. So we have a index, which is the current index. Then we have the output to the my info. Actually, I want to have this as a pointer, because if this succeeds, I'm going to return the info as a pointer, and else just return null pointer. But we need one more parameter. That's the one that I have not in here. I need to enumerate preference. Enumerate order. Enumerate order, I think. Enumeration order. And I basically want to store the order here as well, so that I can pass the order in here as well here. And now I just need them in the constructor as well. So the enumeration order equals by performance is the default one that I want to have, like that. And then I can say my order is the order, and everything is good. And then I can just use the get info function here. So basically what I'm gonna do here is operator dereferenced. Or we do need a Boolean operator actually. Or do we want to use a Boolean operator? No, because we can check and catch invalid ones. Let's see. Probably Unity is currently not planned. I don't have time for too many video series. Currently the only active things that I do is like these streams and the C++ series. But Unity is a good engine. I actually like Unity more than Unreal. But it does not support C++, or at least last time I checked, Unity doesn't support C++, which is something I don't like. But yeah, that's how things are. And so T-reference, operator, dereferenced. And I return dereference get info. This can fail, right? But that's okay. Actually, it's just a const T-reference, as well as a const T-pointer, operator, pointer, const. And this one is now accept. Return get info. And now we should be able to iterate over them. However, we need to be able to create iterators. How do we create iterators? I don't know. Is this standard library actually supporting templated begin and end? Oh, that's the C language. I have no idea. But basically what I want to have is like a template type name T. And then basically T is like the iterator type begin. Or actually I could even wrap this even further. I could like say iterator of T begin. And then basically it's like return iterator of T. And how do I construct it again? Parent order index. So parent is this, order is something, index is 0, and the end index is going to be interesting, but we're going to get to it. How do I get the order in here? It's very simple. I can just plunk it down in here. How would I call this? Enum order. And just push it in between here. Then you have like the end function here, which also takes the enum order. However, that's not going to enter 0. This needs to first find the index. So invalid index is going to be equal to 0. And what we basically going to do is while okay, so bool retrieve result. It's going to be like that, and I'm gonna have a do while loop here, and while the retrieve result is true, I'm gonna do stuff, and I'm basically gonna need to enumerate that. So I'm gonna have the T in here, and that is gonna be my temp out, and I can now use the get GPU info function. So the retrieve result is equal to the get GPU info function. This is gonna get the invalid and index plus plus. So post increment, get the current run incremented. If the current one doesn't work, the next one is not the invalid one. Okay, so we're gonna do pre-increment. Start at -1. This should work because it's then overflowing and back to 0. So we pre-increment so that the index is 0. And then it's gonna 0 be the first one that's invalid. Yeah, that should work. So next parameter is the output. This is gonna go to temp out. And the order is gonna be the enum order. And this should give us the last invalid index. So first compute. First invalid index, not the last one, it's the first one, right? And then we can use that index to create the iterator. And now we should be able to iterate over the class, or the GPUs. Let's see if this works. This is like hell a lot code for interface. It's more than an interface, however. It's more like a hardware interface base. It's a nice thing. We can always change this with Visual Assist and it doesn't screw us up. Now we can go to my minimal app and try this out. Oh yeah, my debugging interface. That's something that we need to do as well, so let's just temp it in here. And let's see. Let's include HAL, contract, RI, hardware interface base. Let's try to retrieve all the GPUs that are on my system. And print them to a message box, because WinSDK is there. So how do I do this? Here. So let's see if we can do this. Auto. Let's just call it GPU in PDK all Windows DXGI instance get instance. This is probably not working, right? Because it's templated. However, if I tell you what type it is, what iterator type it is it then working with templated ones? If I say like this is a DXGI or a PDK HAL Windows. If I tell you that is that one, does it work then? Okay, it doesn't work. Alright, so we don't need to do a plain for loop. Okay. So auto it equals PDK HAL Windows DXGI instance get instance. However, no. We can solve this. We can actually solve this. We can solve this. I'm not an idiot. I know how to solve this. We can do it. We can do it. Basically, I'm doing it like that. Iterator. Okay, no. RI. Iterator of GPU info DXGI begin. So inline begin, and this is gonna then return parent begin. So begin templated with GPU info that one. Right? Not right? Or how does the begin function look if it's templated? Or do I need to say RE hardware begin? That one? Yeah, that one. Yeah, let's do real brackets if you really like to. And this can now maybe alias that. Yeah. Now we should have a lib over that. And let's do it in the message box. The text is gonna be the GPU dot... Okay. This is not the right class. Okay, this is not working. You should be the iterator type, right? What is going on? Iterator T. Iterator? Begin? Hey, are you detecting this wrong? Let's try it out if this works. It does actually. So this is a IntelliSense issue or Visual Assist issue. Okay, but it works, right? So I'm fine with that. So your GPU is... Let's see if it builds. Okay, it doesn't. So what I really need to do is I need to really hide them. This should hopefully not allow the creation from our base class. Okay, they don't. Alright, so I need to do it the classic way. Let's do the classic way. This is gonna be blown up. Biggest fire in the world. But that's not really how it's then finally meant to be. Were used, however. It's probably then easier to use it in the normal loop with the default function, but we're gonna see. Let's go this over here. Actually, plus it. And then it name should work, right? This one should work. No. What? The operator equal was the issue. What? The equal operator. That one. Why do you have two overloads? Nah, don't have. Two. That's odd. That's really odd. That's so odd. Alright, let's see if we can get some info from the output. Alright. It could be... Okay. GUID. Const GUID. What are you trying to do, Microsoft? Why GUID? That one really has nothing to do with my function. That is some Microsoft stuff. I mean, I get that one. Do I need to explicit like that? I don't care. Really. People should just use a for loop. A damn old for loop. It's not worth debugging an iterator. That is that bitchy. It's also like a bit too much. If I would do this maybe properly and works too much code actually for just a hardware abstraction layer. This should be very, very simple. Right. So this can be again that one. So this shall build now? No, because I haven't changed the code in main. Or not main, but you get the point. So what you really do is you do a while. Now I have removed the message box. DXGI or PDK, RI. No, actually Windows, because we are on Windows the whole time. DXGI info. Size T index. Index. X equals 0, and what you're doing is while PDK HAL Windows DXGI instance, get instance, get GPU info, for info, index, info, actually index plus plus and info. Then you want to output that as a message. This is your GPU. Let's see. NVIDIA GeForce RTX 3090. I sadly don't have more GPUs in my system, or would mean sadly, but sadly because I can't test if the code really works, but it should work. Oh no, I have multiple ones. Microsoft Basic Render driver. Alright, this works, so actually we can make maybe a breakpoint and do a bit of debugging so that we can actually see the render pointer. So if I would have open up info, can see that we have a GeForce RTX with just a hardware GPU. It has video memory and shared, which is right because it's not on the system memory. That's all good, so I get the message here. Now the hardware, Microsoft Basic Render driver, it's software, it has no video, no system memory, it has just shared memory. That's also correct. And if I would continue on, we are done. Now let me maybe do it energy efficient. Let's see what happens if I want to get them energy efficient. So I'm gonna quickly enter the code. I changed the code here. I'm gonna keep zoomed in. So it is RI. Now let's maybe first check the default enumeration. Is it enumerating the RTX GPU first? Yes. than the basic renderer driver. But I think the basic renderer driver is always the last one, even if I go low energy, because it's not really meant to be used, right? But let's see. Yeah, it's always going to give me the RTX one first, because the renderer driver is really like the fallback device. That's always going to be the last one, no matter how you are enumerating your GPUs. So that's not really the point here. But what we can do here is enumerate them in a certain preference. But we're always going to have it performance. So, like that, basically. And this is like it's a bit more simpler than writing like the all big code for the iterator, which is even like not even more performant, which is just nicer to use if you're having the for loop. So it's not really a point there. Sometimes need to know when to stop also writing some code if you are seeing it's going in the wrong direction. So that's the thing. That's important. Okay, so we have implemented them now correctly, the enumeration of the GPU. Now we can maybe try a few things out that we want to do with them. Are there any more information that is like essential for us? That's a big question. But we can find this. What information does the adapter have for us? The adapter 4, let's see what it has. Okay, the description 3. What does the adapter 3 has? Video memory info is the current one, I think. Node index, memory segment group, memory info. This is like dedicated system shared. Oh, local and non-local. Okay, even simpler. And it's having this video memory info. It's getting a budget, usage, available for reservation, and current reservation. So the whole budget, what's currently used, and like the reservation status if you are reserving memory. But that's maybe something that we want to do somewhere else actually. When we are creating a instance of the GPU, we might want to get the adapter and store it in the instance itself so that we can use the adapter to like query information and stuff like that. Register hardware content protection teardown status event. Hardware content protection. How is it working actually? It's DirectX 11, right. It's also something that we don't care. Set memory registration and register budget change. Now, also something that we don't really care, at least now. Let's see what the adapter 2 offers us. There's no just a description here and just a description. Alright, so we have everything available that we might need or potentially need in the GPU info here. Alright, so what we now can do or should do is actually instantiating the GPU. Yeah, that's right. That's what we want to have. So basically what I want to have, I would like to have I hardware interface, and what I now basically want to have is I want to have an how did I call this? Let's just call it iGPU interface. It's not iGPU for integrated GPU, it's for interface. Hi, welcome to the stream. So iGPU interface. This is like the class that holds the interface to the GPU. And it's by default, I don't really need something in here. Now the only thing that we need to vary now is memory management. Should we just use new and delete on them? Nah, we might want to use allocators actually. Hi, welcome to the stream. So we want to use our allocators for them, that's the thing. Oh, come on. make a virtual destructor here. Now we should be good. Now hardware interface should now also be able to instantiate the GPU. So we're gonna have a virtual. Okay, now we need to include the header. GPU interface. And basically what I want to have is a virtual GPU interface pointer. Create open interface, because we want to open an interface to the GPU. And now we basically input the GPU info to which we want to open up the interface. Now what I also want to have is I want to have the type of hardware abstraction layer that we have. I want to have them just as an enum in here. So enum class hardware interface. How do I want to call this? It's like RE renderer infrastructure implementation. So RII actually would be the short name. Which theme am I using for Visual Studio? I'm just using the default dark theme with a Visual Assist colors on top of it. I think I changed a few of them. So I already got this question on the Discord. So I think in the Discord there should be like the registry file that has all these things in there. So yeah. I just call it RRI type, renderer, rendering interface implementation type. Yeah, I think that name is something that I like. So what types are gonna have? I'm gonna have D3, D12, and maybe Vulkan. Let's just put in Vulkan here for putting it in there. We're gonna later on have this. This is basically so that you can decide what you want. If you want to have like DirectX 12 or Vulkan or whatever. The get GPU info is something that is then a bit different, because we're going to use always the XGI on Windows to enumerate the GPUs, and then if we later implement Vulkan, we basically need to take the name and match it to the correct GPU. I don't know if this... I mean, Vulkan supports its own enumeration, however, yeah, we're gonna see. For now, we're also just gonna support DirectX 12, so probably like there's no point in currently putting Vulkan in here. However, I do want to have the type here. Preferred type. And this preferred type shall automatically deduce itself. So let's add a few functions. So first of all, we'll get RII type support, which should return true if the type is supported. And then I would have a virtual RE type get native preferred, or get preferred RI type const no except, which shall basically return the type that is supported by default. So all virtual functions, pure virtual functions, and then I think I can just call this down in here, or can I? Okay. I don't think that I can do it like that, because... Okay, so then we need to do it like that. And we're gonna have an... copy that function over. Which is basically gonna return open interface, GPU info, this get preferred RTI type. This is the thing that it should work. I mean, we are kind of like violating the interface type, however, this is just to kind of like deduce the default argument. We'll move it away. Okay, so now we just need to implement these. What? Where is my implement virtual methods? Implement interface does not work. Okay, nice. So we try to reopen this and see. Alright, so we're gonna do it manually. Like that. So let's put them all in here. Right. Const no except override. Yeah, the idea is to have both of them actually. So I do wanna have like a Windows implementation and a and an implementation per hardware interface. So the idea is that actually the Windows interface itself, which is like its own abstraction layer, basically knows which features are enabled on it, and so it can basically then, on the open interface function, return you either an object from the like DirectX 12 implementation or the Vulkan implementation. That's like the basic idea. However, it would basically be then more sufficient to also put the enumeration in there as well. However, I have now just implemented them the simple way in basically implementing them on the side of Windows itself, because like the XGI is the only window thing, and I want to have the XGI and DirectX stuff in the singleton, of course, and or not in the singleton, but however, like a singleton that can dynamically initialize and shut down itself, like how I've done it here, like with init and shutdown. So basically, I want to have singletons that are always available in the static libraries, and then basically these come around. This kind of like breaks down by getting GPU info. However, it's actually not an issue. I think the name should be kind of like sufficient. If you have like 2 GPUs, this might break down. However, I think, yeah, we can see this. I might move this off actually, then that like get GPU info is going to change in the future, but I'm just going to keep it as now, since I only implement DirectX first. So if I later on implement maybe Vulkan, then I'm going to refactor this again, but for now I think it's okay. And basically the object returned by the open interface function is then gonna be already in the actual implementation, so either like the DirectX 12 implementation or the anything else, so on the per API abstraction level. Where is my... wanted to open that. Wanted to open that. There we go. To restart music. This GPU info base, this might be also, like if you are like getting the GPU info, you could also add a parameter later on that then calls the right API to get the GPU info, that this kind of like stays the same. I mean, then it kind of like would need to move outside the DXGI instance. This is kind of true. Yeah, it's not ideal, but I think I'm gonna either I rework this after the stream or in the future. But at some point this is gonna change, alright. This is not kind of ideal. It's kind of like grown out, because initially I planned to not include like all this abstraction layer stuff just yet. However, I now thought that I'm gonna do it to just be 100% on a good base, but yeah. No, don't rename it. I also need to see how I'm gonna change it in the future. In the future I might change it that this is like all compiler, at least like all the Windows things that are on Windows on the per operating system or per platform base are gonna be tried to be 100% mapped by the compiler, so that you don't have like virtual pointers, and maybe we can get around this completely. But I'm gonna see. The compiler might be able to optimize this away if I do this properly, but it's something that I need to take a look at that as well, if this is an issue. However, currently I think it's okay. So let's do this quick support check. Basically the idea here is just add everything to that switch and add this basically everything that's valid, maybe with fall throughs. Or just direct returns, I don't know, would need to take a look at the disassembly, what's more performant, but currently we just have DirectX 12, so we could actually boil this down even further, but I'm gonna do it as a switch from beginning on. So it's a bit more expandable than just an if. Preferred one, simple. Open interface. First of all, I need to get the proper one. So GPU. Yeah, at least on the renderer side, it would be required to do the virtual, but on the Windows side, not on the rendering side, on the Windows side, it's possible. On renderer, it's true. Yeah, on the rendering side, you need virtual because it can change. That's true. Depending on what the user selects. However, I'm gonna first like do all the support on DirectX and then Vulkan, because I know DirectX and I don't know Vulkan. And I think DirectX is even a bit simpler, like how Microsoft is doing that with the structs, like the numbered structs, like the 3D12. What is a good example? Do we have one here? Like the 3D12 auto breadcrumb node. Like this is like the old one, and if you need more features, take the one. Need even more features, the 2, which is currently not available. Instead of like these chaining of structs on Vulkan, which you probably can try to move away to templates, but this would be like a pain to implement. So I'm gonna do for DirectX 12 first. Yeah, that's true. I really like DirectX from the API standpoint, and all the debugging tools like Inside Graphics, Pix. You have so many tools. If you don't get along with Inside Graphics for a certain issue, Pix might help you. If Pix doesn't help you on things which do really happen, I do rather like debugging pixels with NVIDIA and debugging geometry with Pix. So many tools available as well. And the debug layer is way more like the debug layer basically tells you everything. If you're having an issue with a resource, it says, hey, resource in the wrong state, it needs to be that state, but it's that state, it's illegal because that. And that's really nice also. So let's try casting this with the proper information now here. So this is going to be the DXGI info. Okay, we can again make this simpler. DXGI info. I don't know when they added these labels with double control. I might need to disable this at some point. Alright, I've actually forgot something. No, not exception, memory. Memory allocation, it's always something that you should at least have in there. Alright, so the preferred type was asked. How did I implement this in the interface? I think it's like that, so I would like to have the allocator before that. And of course then include the allocator here. than the DirectX header. Or the XGI header. So like that. Yeah. Union plus enum flag would be possible, yeah, to change this then. Then this would be working as well. I mean, yeah, you can use virtual on enum and the flag. I'm gonna see. I'm just gonna keep this now in the stream here as is, and I'm gonna overthink this after the stream, and then I'm gonna see how I'm gonna implement this. Like, I personally like to have it so that each, like the DirectX abstraction layer can have its own implementation. The Vulkan layer can have its own implementation. It's always nice if you have like already a predefined class with some common things that you need. And then you can also like store this later on in, I don't know, I think, yeah, the flag is probably something that you want to have. I might also have something like, probably gonna have like a function get hardware interface, and the get hardware interface function then is gonna take probably the RII type, and it's gonna give you the proper hardware interface that then does its things. It's probably how I'm gonna restructure it. So maybe a function to get preferred and supported RII types, maybe just an enum RII types, and you're gonna have a support primary and maybe an unsupported or something like that, so that you basically get the features somehow that are currently enabled, which could be would be something that you could also like do just with macros, the preprocessor. But I'm gonna see how I'm gonna do this. Okay, yeah, default argument. This is a good point. It's like that, yeah. Now I just need to add this. Yeah, that's kind of like the idea. The thing is, with DXGI, you need to kind of like create the adapter before the device to get informations about them. So if you want to have like a selection box, which GPUs you want to use, you need to get the adapter first so that you have a name. So the idea is then to basically enumerate with DXGI, and yeah, yeah, the client is just gonna get the information, so yeah, but however, it's just mainly because of the name, so that you know which GPUs are like in the system and how they are prioritized by performance, by energy, however you want to kind of like enumerate them. Mainly probably gonna be by performance anyways, but it's like the idea, so that you get the right order that you want to get them and have a name, so that you might also be able to allow the user to say, no, I don't want to use that GPU, I want to use the other ones. It's the only idea here to split this up, really. Or the main idea that I had behind that. Probably what I'm gonna keep is probably in the DXGI interface. Where has it gone? There. Gonna probably keep the get GPU. There should probably be a buy in there. Get GPU by preference or info by preference. This one is going to stay probably, but I'm going to move them away from here. I'm going to move them away probably to a own implementation like DirectX I hardware interface, and then the DirectX I hardware interface is going to be retrieved independent from the DXGI instance, and then the DirectX hardware interface is going to access the DXGI instance to then enumerate GPUs using that function here. That's probably how I'm going to do this. Maybe I'm just going to quickly implement that one, and then we can actually go and implement that actually, now that I know how I would want to do this. Let's quickly add in the allocator here quickly. I mean, that function is not going to get implemented now anyways, but just so that it is complete. So I'm going to pause here and go into the factory itself. So what we're going to do, yeah, so what we basically want to do now, so now we need an implementation for DirectX 12. So let's go to implementations, scan your folder in, steal the build file. Right, that should be everything that we need to do. Reload the project. No, I don't want to save something. Saving is always bad. Destroys the premix generated stuff. There we go. Now we have the DirectX implementation here, and we can now fill this with a... How did I call this? I think iHardware interface. So D3D12 hardware interface. This here, this is D3D12, or do I do RI D3D12? Actually, I like to use them just like that for the implementations, to have them a bit shorter, I think. Be good. So let's now first refactor the interface. The hardware interface now, that one is still required, however, we don't need that one because the interface is now already bound to a type, so we also don't need that one. Open interface will now also be quite shorter. So kind of like just like that. Make things also simpler. Probably a good idea to do this. D3D12 hardware interface. This is a public, whatever this class is called when I have included it. Hardware interface. So now we're going to give it 2 functions here. I should have now finally thought of putting the names properly in there. Ah, great, now it's added all the implementations again into the header, of course. I like my stylings, even if you don't like it, Visual Assist. So there we go. Now we have the 2 functions in here. And now the idea is to migrate the source code from the DXGI implementation. So first of all, we are no longer implementing this interface here. We still have that one, which is now should be public. Get GPU. It's not actually not a GPU, so I'm gonna probably rename this to GPU info by preference. No, I no longer implement this interface here. Which should then throw us some errors in the source code. This is fine. So did I? Yeah, it's not required. So you should now yell at me. Get GPU info. We're gonna migrate this in a second. That one shall still be good. Yeah, probably because we have some issues down here. Get support and type. We don't need these two. Open interface, the first one that we can migrate. You of course need the implementation. Okay, that's the wrong package, so this is Windows. Now we just need that one. We'll do see things here. Okay, now I don't have, okay, if I don't have the header, of course okay, so I still need the header here for getting the base things. Okay, the base class. Yeah. And we can now use them in here, Windows. Now, instead of directly doing this here, so Windows, DXGI. Like that. I should be able to just quickly call into DXGI for retrieving the data. And now I have the adapter separated, and now I just need a way to get the adapter itself. So for the adapter itself, we would need to have some code that is always present. So the idea is actually to have a mapping package. Already planned, we wanted to have this a few code sessions ago. So we're gonna have a mapping, hull mapping. And the mapping is then gonna be responsible to give us the right implementation on the platforms. Oh, did I? That's actually wrong. This should be always hardware abstraction. Hardware abstraction Windows. Hardware abstraction D3D. Okay, no, this was mapping. Didn't change it yet. Mapping. In there. There we have our hardware abstraction layer. Giving this a little tab should update our projects correctly. Oh no, we don't want to save something. Visual Studio. Give us a mapping package. Or a library. I mean, like, it's not really a package, it's not Python. Or Java, or whatever. But module. Module is okay. Okay. So, now in mapping, we can now create a... Oh, yeah, thank you for the subscription, Hackers Tech. Ah, you already written something in the chat. Yeah, thank you. I always get shocked when the default Streamlabs sound plus animation gets, because I'm not prepared for them. But yeah, thank you. I do need to spend some time into creating custom ones. Maybe a custom sound. Alright, so we need a mapping for the rendering infrastructure. Rendering infrastructure. Probably mistyped something there. So we're gonna be 100% sure and double check this. Alright, so mapping itself. It's gonna be in the core hull package. So first of all, I do want to have type diffs. I want to have type diffs for the proper classes on proper systems. However, I don't think that we need one yet. Do we have something that is Windows dependent? Yeah, for the Windows stuff, for Windows itself, for windowing. But this is not something I want to do now. Timers are not started at all. So DXGI. The only thing that we have is the only mapping that we need for graphics is actually the type here. So basically the GPU info type. So what I want to do is... Do I put this in the rendering infrastructure sub package? Maybe. So basically... I could use using as well. Do I use using? I think I used using quite often now in this project. So maybe we are using. Okay. Hardware abstraction level, implementations. Now first of all, let's include the contracts. Let's start with the contracts. We need that one. And we need that one. And then we need the implementation. So if dev ProEdge Windows. Come on. Do I not have that macro? Actually, I think I have a ProEdge GFX Windows, especially for graphics. I think I defined something like that. Or not? No, there it is. No, GFX debug. Okay, I just used GFX debug. Makes sense. Because debugging graphics might be decoupled from debugging the engine or debugging builds. Because in future we're gonna not afford debug builds. And that's why we need some manual flag for graphics debugging. So I want to include something here, PDK, hardware abstraction layer, now the implementation for Windows DXGI, and the implementation for D3D12, the hardware interface, so that we have both implementations that we need to map them together. So first of all, using... Ah, that's always nice to see these nice chat messages. So, there we go. Away of spam. Spam eliminated. So, I personally did not use using that often. So, I'm probably gonna do it the wrong way around when starting with it. I think using was getting the new name first. GPU info equals GPU info DXGI. No? Okay, because it's in Windows DXGI, but that's the idea? Yeah. Okay, so fdev ProEdge Windows, we want to use it like that. And if we have... Okay, no, we don't want to use it again because this is dependent. Again, that is a mistake. But we're just going to have functions here. We want to have the I hardware interface pointer. And now I don't need the allocator there as well, because the interface itself is already going to get an allocator. No, because it's going to be a singleton. Okay, no, we don't need an allocator here. So we want to have a function called get hardware interface. The get hardware interface function does take an RII type. Then what I also want to have, do I want to have them as a nice little table that we can iterate? or just as two simple functions? I think we're gonna have two simple functions. So we have a boolean get RII type support, like that. Or these ones, we could actually do them, could redirect them to with the preprocessor actually, then we would not have code in the mappings. I don't care, we're just gonna write code. Okay, so we want to have the support, and I want to have an RI type, get default RI type. So this should be sufficient, all functions that we need. And now the implementation depends on operating system. For the RI type, we can actually do this quite simple. We could define ProEdgeGFX default RI type. We could do this like that and define it on Windows to be the RI type R. Okay, of course, do I want to have this full qualified? No, I think it don't. Maybe we're gonna do it full qualified because this macro might also be used somewhere else. That we can make this inline. Let's actually make this an inline const expression, because never gonna change on a build. We just have the two functions that we need to implement. These ones are gonna be quite easy. Do a plain switch on the type. No, yeah, there as well, but here as well. So type, and I have the case D3, D12, default. The type will basically just return. Okay, I don't think we have a boolean yet. Can I? It's preprocessor only, or I could redirect them. I'm not quite sure if I want to redirect them to Windows implementations maybe, or just do it with I think I'm just gonna do it with preprocessors. So we're gonna do an end if. So we're gonna do it completely different. We're just gonna it's like that. So that, like, I could also put the else in the break in the end in the else if, but no. So I can basically then check if defined, or later on if we would have like Xbox or something like that, we could factor this in here as well. So now we get the type support. Now basically what I want to do here is I want to first check if we support that. Then we want to actually call into creating these things. But we might actually we don't need this really. These ones I'm gonna if I'm gonna do this like that. ProEdge. I don't know why Visual Assist is not liking my macros. I just want to redirect them this time. Or make things a bit cleaner. Aha, function definition not found. Schön, that's nice. It's directly there, but okay. That. Do I wanna... Actually, I think I'd rather have an empty implementation on other operating systems. Maybe not. Then they are guarded here as well. And now I can write my nice little switch. Power pointer. And in case we are on DirectX 12, I'm gonna return something later on. Alright. Now I just need to make the hardware interface as I like it, and to make it to my personal preferences. I'm gonna make it as a singleton. I have my instance in here, and I think inline static does work. For static inline, there was a way to do this directly. No? Yeah, we just go with default. I thought they have come up with something yet. I know. I don't care, actually, if I make them inline or not. I'm used to have them like that. Now we have an instance. I'm again in the wrong header. Now we just need a way to get it. My hardware interface, RI hardware interface, reference, get instance. It's gonna return them my S instance. Yeah. I have a singleton down here. Nicely separated, written wrong. Now everything is correctly defined in here. Let's now use it. The rendering infrastructure CPP. Let's first of all, I already included that. Nice. So D3 D12 get instance pointed to that. And now this should be linked up together. Let's now find out if this works. Do I still have my example in here with enumerating the GPU? Yeah. This one should no longer work, right? Yeah, this is no longer working. Now I should be able to call my HAL implementation mappings to open them up. I can use some mappings. RI get hardware interface. For example, DirectX 12. This is a pointer. I can now use GPU info. Now in theory this should do the same thing, but nicely encapsulated. Yeah, we still have the problems with the imports, but I do got a message box. Yeah, NVIDIA GeForce RTX 3090. and my Microsoft Basic renderer driver. So this works. Good. Now this is way cleaner. Thank you for the suggestions. Alright. So, do we have anything else left to do there? I think it should be for now. I think, yeah, of course, we need to implement the function here for, no, hardware interface, the open interface function. This is currently empty. It's just checking that it gets the XGI info. And if it gets the XGI info, it now basically needs to create the internal class. So DirectX 12 would have a D3D12 GPU interface. Oh, I've done it. PTK PAL D3D12 class D3D12 GPU interface. Yeah, maybe lowercase is better. I do like lowercase. We're just gonna... I always written it caps. No, I'm not gonna change anything. I rather have something that I don't like to look at. Alright, so this is now a PDK hardware abstraction layer contract GPU interface. This is now gonna hold a few things. So we need some Windows stuff. We're gonna take the DXGI instance here because it's like defining the functions that we're gonna use in the future. Not all are available yet, and the COM pointer. So what we basically want to have here is we want to have an IDXGI adapter 4, which is the PU adapter. And we're gonna have an ID3D12 device. How are we? 10, 11? No, 10 is the latest one. D3D device. Or let's just call it GPU device. To then have both of them together. We're gonna of course also have debug things in here. So if we are on debug, we're gonna have DXGI. Oh no, how did I call this? ProEdgeGFX debug. We're gonna also have a bit of debugging stuff in here. ID3D12 debug device. Debug device. So that we can have debug informations there as well. Now we just need to implement these. It's gonna be quite simple. The adapter is gonna come in. Let's say, do we want to have this as a raw pointer, or do we just take a COM pointer? No, I think we're just gonna take a raw pointer. I mean, my COM pointer is designed to work with them. So, adapter. That's the one we're looking for, and from the adapter we should be able to create all of these. I want to have a default constructor maybe. I don't want to copy these. But I do, however, want to support my move. Destructor, no, we don't need one. These are all cleaned up automatically. I don't want to have an assign. Don't want to have that. However, I do want to have my move. That's what I want to have for basic, basic class functionality. However, I do need more things here. I do need the memory allocator actually. So include PDK, engine, util, memory, allocator. Because I do want to store an allocator. So we're gonna have a memory allocator to allocate sub-objects and stuff like that, GPU-related things. So I do want to have allocator. I don't know, does my allocator support move? I don't think. Then I could have like implemented a default. Yeah. Then continue on with the construction of that object. What? Oh, okay, this is move assign. Okay. That makes sense. I think I can just copy. Allocators don't need to be moved. It's okay. So how does the move assign work? So first of all, the move assign needs to call the current destructor so that we make sure that the current object is cleared. No, not the iGPU, that one, the correct one. Then I need to move over from the other one. So what I do is I like to do, and I already forgot how to. Where's my example for this? It's in a different project. Placement new. I think like that. No. Placement new. Always don't know how to write them. Don't care how that works. I just care about that new buffer string. Okay, I need to type as well. Okay. Right. That one. Right, so this should delete the current content and then call the move constructor, which is basically moving everything from the other one. Only things left to do is return the reference this. And now I can implement everything in my move construct. Alright, so what do I need to move over everything? So my GPU adapter equals std move other my GPU adapter. We just added these in last stream, I think. GPU device equals std move other GPU device, and if ProEdgeFX debug, I want to also move the debug device. I mean, like, it's not really required to move DirectX objects because they can have like half ref counting and counting up, counting down. Yeah, it's of course more performant if we move them, so we can use it. So this should correctly move everything over. Now we could start adding functionality. However, I don't want to add functionality yet. I just want to create that one. so the hardware interface in the open function here, we basically want to create that new object. So what I'm going to do is basically, I'm going to return allocator, new object, and I want to create a implementation, v3d, GPU interface. The v3d12 GPU interface. That one, I want to create that one from. Okay, first I need the adapter. This adapter, we're going to get it from the XGI in a second. So let's just add a null pointer in for a second. And the last one is the allocator. And this should create that object, right? No, because this is not a reference. Reference wrapper. Now this is a reference, and this should work. If that null pointer goes. The null pointer goes as soon as we implement the features in the XGI. So the XGI needs another helper function. It gets an IDXGI adapter 4 pointer, get adapter by a local unique ID. LUID like that, and then we can get adapter here. And how do we get the local unique ID? It's very simple. The adapter with the local unique ID. I'm asking my factory for get enum adapters by local unique ID. It's gonna get the local unique ID, and it's gonna IID PPV arguments, and the IID PPV arguments are gonna go to the IDXG adapter, and we're basically gonna get to that, and then we return it. We don't really care about, or maybe we want to throw if that fails. It should not fail if you call. If we are getting so far, it shouldn't fail. So failed to retrieve adapter by known Luit. Then we can return the adapter. Right, it's a bit more cleaner if we're doing it with checks. Now we can use that function to generate the adapter. So basically what I want to do is I want to go back to my DirectX 12 implementation. Or is it here? And I want to say comp pointer to an IDXGI adapter 4. Adapter is going to be equal to Windows, DXGI instance, get GPU info, no, adapter by local unique ID, it's in the DXGI info, there is the local UID, can get the adapter here, and if adapter exists, I want to return new object, and now I basically add in the adapter, which should, I don't know, is that conversion? I think I want to call this with getRef. Yes, I should be actually more called getAddRef, I think. Because if it just call get, I just get the pointer. However, do I add ref if I create it from a pointer? Set pointer and add ref. Yes, it is doing it when I do it from a pointer. Okay, so this works. And I think that the normal conversion operator is just returning the pointer. So we are actually good without adding ref, so we are gonna have too much references. So it's just sufficient to do it like that. So here we get an object with... Okay, no, this is not working. Because this is already having a reference count of 1, and initializing that is gonna add another ref count on top of that. It's not good. So actually this function needs to return a comp pointer. Then we are good. Then we are good. Then we are gonna go to copy here. Copy is used, that one is discarded. And we could even like move this. But we don't need to move this. Just adding two functions for the sake is not really something that we want to do. One thing that we need to do now is we need to copy the GPU adapter to the adapter pointer. And now we just need to initialize the device. So what we basically want to do is we want to call the 3D12 create device function. The adapter is my GPU adapter. Feature level is going to be 12.0 for now. Something that we might also want to customize, but yeah. And GPU device, this shall be checked. So how was the function called? Check H result and throw. Throw edge. Check. I don't know why today my IntelliSense is not really just PDK. Okay. So we want to call that function here. We want to check the H result and throw. Failed to create DirectX D3D12 device. And debugging is just query interface as soon as the debug layer is on, I think. ProEdgeGFX debug. We're gonna say GPU device query interface to debug device, and that should be it. I could like, as is returning bool. If this fails, I could also throw, but I think it's okay. The debug interface is not really too hard required. However, I do think I want to have a custom destructor now I think about it. I want to release them in the order that I like. No, wrong header. I do want to have my own destructor. Just want to assert that I destruct them in the right order. Release as well. GPU device in here, adapter in here, release them, and we should be good. Let's see if it works. We need to first, of course, implement this. So what I'm basically just gonna do . Auto RI is this one, and RI pointer wants to get the GPU at position 0. Of course, auto pointer. So there we go. And then I basically want to say RI open interface. And I want to open an interface to my info. Or let's not call this info, let's just call this here GPU. 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 And this is then an auto pointer. Info. Equals open interface. GPU I or I GPU interface GPU. And let's see if this blows up. Yes, it blows up. Let's expect that. Because probably I think what? Could not it use type? No, it's above here. I'm an idiot. Okay, so ID 3D12 debug device. I thought this should be deduced automatically. But yeah, might not. Okay. This is not including a pragma once. Which idiot has written that file? Was that me? This should give us way less error. So it's actually giving us no error here. This one, I need to take a look at them. They need to be going away. Oh, it's actually a uint. I'm tempted to just convert it to a uint. I know, this is something, a problem for future Fusel. Okay, so what do we got here? Let's inspect them together. Alright, so we have our GPU, which is the RTX 3090, that's correct. We have the iGPU. The iGPU is a D3D12 GPU interface, which has an allocator, which is the default memory allocator, that's correct. It has an adapter, which is an IDX GI adapter 4, that's correct. It has a GPU device, which is a device 10, that's correct. And it has a debug device that has a debug device 2 pointer. So this works. We have everything that we need in here. So code works. Only thing that I want to still do, you can see like this open interface works, I do want to have a destroy function. That's important that the devices shall destroy itself, because they have their own allocator, they manage their allocator, so they also should delete themselves, which sounds silly, but is what it should do. I hope it's not screwing us up, but it shouldn't. Nah, phone is ringing. I can't get my phone to shut up. Okay, somebody else answered the phone, that's good. Now I can shut it up because it's no longer ringing, and if it's no longer ringing, I can shut it up, but if it is ringing, I can't shut it up. Amazing. Yeah. Just transferred the call back to the next station. Right, so that's how we want to do it. So virtual void destroy. And this destroy is for real. Deleting the object. Pointer no longer valid. We're gonna have other objects that are gonna be a bit smarter than that one, but that one is gonna be one holy pointer. We're gonna have a bit more C++ style objects as well. Okay, so let's implement the destroy one. Oh, come on. Why is my Visual Assist today a bit bitchy? How's the implementation going to be? Very simple. Allocator, delete object. And the object is gonna be this. I wanna quickly see if this can break. Because this is basically calling the destructor of the object and then memory free. Memory free with the object pointer. So this should not break. Because this is just stack. No, that's not what I want to do. Let's see if this works. By basically just calling destroy here. Let's see. Okay. So iGPU should now be a proper GPU interface. It is. What happens if I now go over to destroy? Okay, the pointers get null. That's correct. The allocator itself is probably not changed. Because this is just a reference, it's okay. Now this memory should be also freed. Alright, so this is working. What is it saying if it reports live device objects? It should say nothing. It's actually saying nothing, that's good. If I comment that out, it might say something. Let's see. Yeah, now it's saying something. So that means that this also works. It still tells us that we should call report live objects. I'm calling these function through DXGI. So we are getting the proper report. That one is our proper report. This one is the customized direct. I think this is the DirectX call. This one as well. Well, I don't know. However, we are getting the reports that we have a device with a ref count of 2. Interesting, ref count of 2. Yeah, probably internal and external references, so that's okay. And that's the idea. This is how it works. And this is actually already... This is like the only Windowsy thing that is in there. Which is something that we might also want to change in the future, since this requires a pre... So this actually, and I now get the point why you said that using a flag and a union is better, and it's probably better. So this is something that I'm probably going to change as well. Because the... However, if I do the union, then the LUID is no longer available. Yeah, because now I have like... I would need to dynamically allocate this one as well. Yeah, okay. See the issue that we had there, but that's actually enough for today. I do have, as I already said at the beginning of the stream, another appointment that I need to do, and that's probably going to be the case. I haven't got a message for that one, but there should be any second, as I actually already planned for like a long time ago. So now I don't have it yet, but I need to prepare for that. So thank you for watching. Thank you for attending the stream. I hope you enjoyed. We did a fair amount of coding today. We implemented like full GPU enumeration and creation interface for rendering. We implemented that. Next, I hope that until next stream I can get all the windowing and normal windowing stuff sorted out with hardware abstraction. Maybe the issue here with the GPU info, so that I can sort that all out. And that we can then in the next video... stream, I'm such like the video guy. Next stream then continue implementing a DirectX DXGI window actually for drawing on top of that, so a swap chain window. And that's basically what we want to do. So thank you for watching. See you in the next stream, and make sure to like and subscribe. I mean, like, why I'm saying that on the stream. Maybe there are also people that haven't subscribed, but thank you. So thank you for the subscribers, the attendant people, and everything who was there, and